Okay, we're going to look at hyperbolas. So first I want to give you a minute. You should pause the video and look at the first 3 graphs on that page. And I want you to notice anything that you see that is similar or different, looking at the equations, the pictures. Now that you've given it a little bit of thought, a couple of things that I hope you noticed was that the first equation has a plus sign. The 2 end ones have a minus. And so you can see what happened when we change to a minus. Well, so much is similar. They all have a center at 0, 0. All of them. So 0, 0, 0, 0, 0, 0. At least something going on at 0, 0. Now the first one we already know. That is for sure an ellipse. It's equal to 1. It has the plus sign. It has x squared and y squared. We know the center is at 0, 0. And then the left and right movement is going to be 3. The up and down is going to be 2. And you can see all of that going on. Lots of familiarity there. There we go. And then they form the nice ellipse. Now there's a dotted box around it. That looks kind of weird. But if you look at the other pictures, it's the same dotted box. And look at how it's formed. Those points that we drew on our ellipse are the kind of sides of a rectangular box. And that's the box that's seen in these other pictures. Now, one person has described it to me before that it's as if you took the ellipse and opened it up. You like reflected it out. And so if you look at how this new graph is formed, this is the hyperbola. It's the blue graph that you're seeing right here. They start at 0, 0. They go up the 2 and right the 3, just like we did for our ellipse. But instead of forming the ellipse, they went and made a box. And this little rectangular box has these diagonal lines through it. These are asymptotes that guide this new graph that we're talking about. And this new graph is going to follow those asymptotes. Never cross it. Just get closer and closer and closer. And it kind of looks like 2 hyperbolas going out, but hyperbola is defined a little bit differently. Now, the equation on the third equation and that second equation, you can see there's x squareds and y squareds, there's 9 and 4 still. There's subtraction, so that's kind of telling us that it's kind of flipping out. And that's also telling us that it's going to be a hyperbola. So if there's a minus in the middle, it's going to be a hyperbola. The other thing that's important is what goes first. So when x is going first versus y is going first, because that's really the only difference between those 2 equations. And what's happening when x goes first? Well, our graph will open up left and right. It has nothing to do with the size and the points where these pieces are sitting. Those are the vertices. And again, it's not having to do with the size. It has to do with what comes first. So if you look at the second or the third equation, it has a 4 here. Again, that's a smaller than a 9. But what's telling us to open up, down, is because y is coming first. And so these points that I'm pointing to here are going to be the vertices. Again, the vertices for ellipses, the size mattered. So if I go back over here, those are the vertices for our ellipse because they're on the major axis all the time. Now the vertices are always on the transverse axis. It does not have to do with the size. What it has to do with is what comes first, the x squared or the y squared. So the hyperbola is defined to be the set of all points in a plane such that the difference in distances between x and y is 2 fixed points. That's slightly different from the ellipse. The ellipse said the sum. So to kind of make sense that within our equation we have that subtraction going on. Now the 2 parabola looking things, those are the branches of our ellipse. The points where the hyperbola intersects the line through the foci are called the vertices. So one thing that we didn't see on here is where those foci would be. Well, now the hyperbola is going to open up to the foci. So I just kind of estimated where they might be. Opens up to our foci. And the equation for our foci, if you notice they're now going outside of our shape, they're kind of bigger now, you actually add your a squared and b squared this time compared to an ellipse. So for the hyperbola, to find that c, you're going to add that big guy, little guy underneath. So for an ellipse, remember that it was a squared minus b squared, and that's because they need to fit inside, and the hyperbola opens to them. And it's flipped, so they have to be a little bit bigger. Now, again, it's telling us what's happening if the transverse, that's what that's called, the transverse axis that I mentioned up above. The way that we know which way it's opening is based on which variable's first. So if x is first, it opens up left and right. If y is first, it opens up and down. All right, let's take a look at how we will graph these things and find all of those details. So we're going to look at this first problem up here. Again, it wants us to identify the center. Those are familiar. Vertices, those should be familiar as well. Foci, I'm going to write down that equation so we don't forget. It's the big guy plus the little guy. And then we also have to write equations for asymptotes, and we'll see how those are in our graph. So the very first thing is that we have a center at 0, 0, and I know that because I'm not adding or subtracting from my x and my y's. The other thing I notice is that y squared is first, so that tells me my hyperbola will be opening up vertically. I also see this number 16 underneath the y, and the square root of 16 is 4. That's how much I'm going to move up and down. So it's really similar to the ellipse. The 20, square root of 20, that's how much I'm going to move left and right, which I could simplify that. This is like 4 and 5, so I could take a 4, square root of 4 is 2, and 5's left inside. Which is approximately the square root of 20. It's got to be less than square root of 25, so it's like 4 point something. So let's see what that looks like so far. If I sketch the centers at 0, 0, my left and right movement was a little more than 4. 4, 1, 2, 3, 4. And my vertices, my up and down movement was 4, regular 4. Now these are going to be my vertices because I said I open up and down. And they're going to form my rectangle. So I'm not making a little ovally shape. I'm just trying to make a rectangle. And that's what the asymptotes are going to be able to cross through. So the asymptotes go from diagonal to diagonal, and they have to cross through the center. So I'm going to connect all those guys together. And there's one on each direction. And so my graph will open up following along those asymptotes, and downward following along those guys. Okay, so let's identify all those parts. So the vertices, I had to go up and down 4, so that would be 0 with a 4 for the y and negative 4. Let's see, it says my foci. My foci are found by looking at the big distance and the little distance added together, so that will be 36. So C will be 6. So let me plot those on here. Again, that's from my center. I'm going to go 1, 2, 3, 4, 5, 6, and they should be pretty big because it has to open up to it. 1, 2, 3, 4, 5, 6. There's my other focus. So that would be 0, 6, and 0, negative 6 for my foci. And then the last part, the equations for the asymptotes, and these are equations because they're lines. And so if you think about one of the most basic ways to write the equation of a line is y equals mx plus b. Well, here our y-intercept is 0, 0, so we're going to actually kind of ignore the b. So all we really want to focus in on is the m, which is our slope. So if I am starting at the center 0, 0, that's a point on my line, I'm going to go up 1, 2, 3, 4, just seeing how my rectangle was built. 1, 2, 3, a little bit more. Then 4 is where that's supposed to be. It might be off a little bit actually. But this was over like 4, and so it's a little more than 4. It's going to be the square root of 20, really. So what we just did is we have rise over run. We rose up 4 over the square root of 20 or 2 square root of 5. That's going to be my slope, x. And we'll just leave it at that. All right, let's try that again. Graph the hyperbola, looking for all these details. So my center, first of all, I'm going to the right 4, down 3. I notice I have x squared first, and so that's going to open up left and right. And my center will be right 4, down 3, 4, negative 3. 1, 2, 3, 4, 1, 2, 3, 4, negative 3. There we go. So that's my center. And then I need to be able to tell how much up and down, left and right. Let's see, left and right, because that's underneath x, will be square root of 9, which is 3. And then we're going to go up and down square root of 7, which we're going to approximate that to be, it's a little less than square root of 9, so like 2 point something. So let's get the rest of my rectangle built here. So let's see, 1, 2, 3, 1, 2, 3, up 2 and a little bit, down 2 and a little bit. And again, I know that my vertices are those two guys because I'm opening up to the left and to the right. So I'm going to connect this to make my little rectangle. It's more a sketch because of those radicals. I'm going to draw my asymptotes that go through the diagonals of the box. Right, these diagonals plus the center. And so we have that guy. So those are our asymptotes. And then we know that our graph is opening up, approaching those guys. All right, so to identify those vertices, I know that I'm like at my center, 4, negative 3, and I went left and right 3. So that's like plus and minus 3 here. So 4 plus 3 would be at 7, negative 3, and 4 minus 3 would be at 1, negative 3 now, which you could check that. And then I need to find my foci. The distance to the foci, c squared, again, that's going to be taking both numbers, adding them together, 9 and 7, which is 16. These are nice at least. So c is 4. So that, again, is looking at my center, which is 4, negative 3, and I'm going to add 4 and then subtract 4, or plus or minus 4. So that's going to be at 8, negative 3, and 0, negative 3. And then we can also see from our center, again, it went 1, 2, 3, 4, and there's a focus. 1, 2, 3, 4, there's a focus, which matches up with what we were just talking about. We'll be at 8, negative 3, and 0, negative 3. And then the last thing we need to do is find the equations for the asymptotes. And again, I'm thinking about this graph, y equals mx. And I'm just going to leave off the b. What I'd like to do is think about this point moving by those transformations. It's going to kind of be the easiest way. So we already know that we move down 3. So if I write y plus 3, and with the x, I'm going to put minus 4. And so y plus 3 equals x minus 4, and then I just need a slope in there. So remember, I went up radical 7, and then I ran over, how much I ran over? 3. So again, that was up radical 7, and I ran over 3. So the rise over run will be radical 7 over 3. And you can rearrange that if you want or multiply it out, but this would be perfect. So again, where this is all coming from, y plus 3 matches up with that movement. X minus 4 matches up with that movement. And then you could see the radical 7 and the 3, that rise over run. And so that will be our 2 equations. And now I said 2 equations. I realized that on this one I did not write, it's both the positive slope and the negative slope, so it's plus minus. And if I go back up here, I also need the plus and the minus in there because there's 2 lines, one's with a positive slope and one's with a negative slope. And we could leave it at that. Okay, we got one more. Now this equation is not written in our pretty form, so we need to write it in that form. And so our goal is to write it in something squared plus y squared, not plus, let's undo that actually, because we're talking about hyperbola, it has to be minus, over some number squared over some number squared equal to 1. So that's our goal. So when I look at it, the first thing that I'm noticing is that it starts with some negative. And I know there has to be some negative, but I kind of like to see it in the middle. So let's see what else we have here. It's a positive 5y squared. So I'm actually going to write 5y squared first with the other y term. Then I'll write minus that 4x squared minus 40x, still keeping the 200 equals to 0. So I just put my x's together, my y's together, and I kept my negativity more in the second part. So I'm going to look at the first two terms and factor the 5 out, just like we've done before, getting ready to complete the square. So if I pull that 5 out of the 80, that will leave me with 16. Add something, minus something. Similar over here. Take out a negative 4. I'm left with x squared plus 10x. Add something, minus something. 200 is still just hanging out, equal to 0. So then I think about, well, what can I add to complete the square? So negative 16, we'll take half of that. That's negative 8. And so negative 8 squared will get a 64. And then a 64 here. On this second part with the x's, we'll take 10. Half of 10 is 5. So we'll take 5 and square it. So that will be a 25 minus a 25. Remember, the whole reason for doing that was to make that perfect trinomial square. So that will factor to y minus 8 squared with a 5 still hanging out. These x's will get together, and that will be x plus 5 squared with negative 4 still hanging out. And we have 200 equals 0. And I also can't forget, this negative 64 hasn't been used yet. It gets kicked out by multiplying by 5. Which will be a negative 320. And then negative 25 gets kicked out also. It's going to multiply with the negative 4 and be a positive 100. So then it looks like if I combine together my constants here, negative 320 plus, that's 300, would be negative 20. So I have 5 times y minus 8 squared minus 4 times x plus 5 squared minus 20 equals 0. And so I need to make this whole thing equal 1 and make those numbers go away. So I'm going to plus the 20 over. So we have 5 times y minus 8 squared minus 4 times x plus 5 squared equals 20. Divide everything by 20. I could do it in separate parts, that might be better. Divide by 20. So then 5 and 4 becomes a 4, 4 and 20 becomes a 5, and we get the 1. So it'll be y minus 8 squared minus x plus 5 squared. And we've written our equation in the nice, pretty form. We don't have to graph it or anything, it just wanted us to write it in that form.